Hey everyone, Cranberry Alarm here with our Monday recap. As you guys can see, we got a lot done today compared to what our previous day recap was, compared to our elevator just being on here a little bit loosely. At this point in time, we have finished the entire robot mechanically and are currently parsing through some code bugs and just working out the kinks and getting this robot fully going. But we have a lot of fun things to show you guys today. We've had a lot of things that we've learned about this robot, and we're really excited to demo it for you guys. So I guess the first thing we'll kind of tackle today is we're going to go over the elevator demo. We currently have some manual controls for this. And yeah, so we'll go and do a quick demo about it.
Sure. So currently, well, as Reese mentioned, we've got the elevator hooked up and powered. It's the Thrifty Bot two-stage elevator kit, and for the most part, it's entirely stock. The only thing that we've changed about it is how we mount the motors. And we've actually run into a little bit of issue with that, so we'll point this out, and hopefully you guys can avoid this issue. But we're running 12-to-1 sport gearboxes with Neo 1.1s, and that's powering this chain segment in the back. In yesterday's recap, we didn't actually have that chain on there, but that is what's driving our elevator. We can go ahead and enable it and kind of show this. Again, this is manual control, and it's current limited, so we don't break something, but once we get position control going, we're going to be able to drive this much snappier into precise positions. But as you can see, a lot of people, and us included, were worried about how heavy our end effector would be. There's 4 Neos and Sport gearboxes on there, as well as a lot of urethane wheels. That stuff's heavy. It's like 23 pounds in total, and we're able to easily drive it up and down. We have a video showing how tippy we are with this thing at max height, so go ahead and check that out if you want to see how the robot looks kind of being jostled around. One thing I want to point out here is the cable track that we have running along the side. This is probably the cleanest wiring that I've been a part of on an elevator, so we're super proud to be able to show off something like this. I think it's one of the more daunting things if you're in controls working on an elevator. How do you get everything up to your second stage? I think one misconception is that you have to route up, down, and up for its two-stage elevator, but you really only have to route down like half the length of your extension, because you're already covering half of the max extension by going up the stationary stage. So this bottom part of our cable chain is mounted to the bottom of the second stage, and at max extension we have no issues. It doesn't bind, and we're able to route our 4 motor wires, 2 CAN runs, and 3 signal wires up to the top of our elevator.
Yeah, so I guess while we're on the topic of the elevator, we're going to go ahead and turn off the robot, and we'll do some hand demos of kind of showing the robot near the scoring location. So let's go and get into that. So we got all the coral score on here right now. Let's go and get these guys off. And for now, we'll just drive the robot up to here, and we'll at least show you kind of all of our positions. So our starting configure position is what we're going to be using for L1 scoring. And from there, we're going to extend all the way up, all the way to L4. I guess we'll get this out of here for now. There we go. That's good. All right. Do you guys want to go and lift up the elevator, and we can kind of show the different positions? So all the way up to here would be L3, and then we can go all the way up to L4. And you can see we can extend pretty high past it. And if we actually go down to what we'd want L4 to be, you can see on our elevator we have about a 2-inch gap right there, and that's where the compensation for us being over the starting configuration would come from. If we weren't limited by 3 days, we would be able to fix this, but due to our 3-day limitations, we decided to just move forward and try and pump out as much content as we really can. So yeah, that's how we're going to be doing the coral scoring. And like I said, we've been running into some code bugs, so we don't have the coral manipulator going right now, but we do have a video out showing the coral end effector running off of the Thrifty motor controllers, like the handheld motor controllers, running into the Nova motor controllers. And so far, the results that we've seen with it have been really, really great. So we're really happy with that. I guess the next thing we can show is kind of the algae geometry and de-algifying the reef.
Actually, before we move on to the algae, one thing I want to point out is a couple sensors that we have on top of our coral manipulator. We have one of the laser can, which is a grapple device brought to us by ThriftyBot, and then we have a Redux coloring can. And the point of these, with how our pass-through mechanism works, going from ramp to coral manipulator, we need to make sure that the coral isn't intersecting this plane. Otherwise, it's going to smash into this 2x1 bar at the top. And so we have this laser can pointed down into our end effector to make sure that we clear this sensor, ensuring we can go up and score the coral without smashing into our elevator. And then the second Redux color and Canon color sensor is just for object detection and detecting whether we have a coral in our robot for autonomous deployment. Once we know that, or once the sensor detects that nothing is there, we can be pretty sure that we've fully ejected the coral and we can move on to the next task.
Yeah, so let's go ahead and move on to algae. Like I said, with our reef that we had built from yesterday, we have the reef tree that Andy Mark provided us graciously, and then we also have the ThriftyBot style one made out of PVC and gussets here to kind of represent what the whole assembly would look like. So if we go ahead and actuate up. So for our de-algifier, this whole mechanism right here can rotate out to go ahead and score. So we will go down just a little bit. And what we're going to do is we're going to actuate out, and our bottom wheels are now touching, and that's going to allow us to spin these and then grab right here. And then now we can go ahead and drive away. And then from there we can bring the elevator all the way down. And then now we're allowed, and now we can go basically from here over to the processor, which we'll show at another time. So let's go ahead and get this out, and we can show a couple other different orientations. Let's show the, with us still on the ground, we can actuate our de-algifier all the way up. And then from there, just run the wheels backwards just like this. And then this does go into our end effector area, but if we maybe want a quick D-score, then we just drop it down and then we can go get it later. So this might be really effective for someone who doesn't have an elevator that maybe just wants to do a single pivot mechanism to de-algify the lower level of algae. And let's go ahead and show the upper level of algae. And with our mechanism also, we can also store in the upper configuration just like that. So I'll go ahead and bring down, there we go. Bring it down a little bit more. Perfect. And we'll bring the elevator up. There we go. A little hard to demo with just moving it by our hands, but you can see how the process is pretty similar. And we also found during our testing that powering from the bottom and powering from the top are pretty comparable. We found that powering from the top was a little bit better, but we ultimately went to go for powering from the bottom due to the ease of implementation it has on our design. So yeah. We can go ahead and maybe take a few questions from chat. Yeah, so one thing we really wanted to do is we wanted to be able to pick up from the human feeder station. And this ultimately led to us kind of coming into this ramp design. And from there, we knew we wanted to have a pass through so that we could be able to pick up from behind us and then score in front of us. And that's what led us to have a coral-specific manipulator. And that was our first priority. And then from there, we kind of moved on to, okay, our second priority of algae, and we figured out a way that this could really work out. And then we also learned that there's this mechanism right here is actually very versatile. There's many different things we could do with it. So from here, yeah, Corey's showing really well, and we can also actually rotate this up and use it as a ground level intake to bring it up into our bumper area right here, and then maybe go and score that. So there's a lot of different ways we can use that.
My mic's broken, so I'm just going to try to be loud. You might have to repeat the question. So, Eric asking in chat, it looks like the de-algifier pivots on a dead axle. Have you put any thought into how to sense the position of that rotation?
So we have, yes. So the de-algifier is actually a live axle, but the driving is on a dead axle. So you can see this pulley right here is on bearings right here. So this can spin independently of the axle there. But this axle down here is actually a live axle. And we have an absolute encoder buried down in here so that we can always read the position of the de-algifier.
Yeah, that's just a Rev through-bore hex encoder.
Yep.
We love them. You throw them on, and they work. So, all right. I think the next thing that we're going to do is actually go over to the processor and maybe show what the algae looks like scoring into the processor from the different orientations we collect algae. So let's go ahead and head over there. The orientation we plan to manipulate most of our algae and score from is this one where we've kind of grabbed it from either the middle or the high algae spot on the reef tree, and all we have to do to score the algae in that situation is spin our wheel out a little bit and sort of drops over the lip of the processor right in. We planned our geometry in order to make this work. Another way that we can score the algae into the processor is after our ground intake scenario. So if we're storing an algae like this, all we have to do is run up to the processor, drop a couple inches into the edge of the processor, outtake, and we deploy the algae. We haven't run any of these scenarios with powered wheels. I'm sure there will be a video on that later whenever we get power to that system and we're running it. But from hand testing and previous prototypes, we believe that these methods of scoring into the processor are more than adequate, and we're going to be able to reliably score algae.
Yeah, so with that, we can go ahead and that covers most of the algae that and how we're grabbing and interacting with it. From there, we'll go ahead and move over to the human player station and look at how we interact with the coral and how we receive that from the human player station. So like I stated earlier, we ultimately decided to go with a feeder station intake. We decided that going from the ground is going to be a pretty hard task in Ri3D, and ultimately with the surplus of coral available in the human player stations, we thought it would be advantageous to build a robot around grabbing from the human player station, and especially since we can grab here and then we can look over right at the reef right there and then go and straight and score. So unfortunately, we don't have our coral manipulator running like we did in our previous prototypes, but if you haven't seen it already, please check out this video. It really shows off the mechanism working really well. But we'll at least show you right now kind of how the hopper mechanism works and how that runs. Basically, at this point right here, anytime that these two wheels right here are contacting the coral, it almost always pulls it directly in until that we can manipulate it. So let's go and do a couple of them, a couple more just kind of straight on, showing that off. So there. Here you go. I can just hand them right back to you. We'll do one more, and then we'll go ahead and shift the human player station to the side to kind of show if we're off to the side. Let's see, you can stay there. You can stay there. And there, from here, the wheel would be contacting this face of the coral, and then it would then kick it in this way. And that's worked out really successfully for us, and we feel really confident moving forward with this design.
This was probably one of the most anxious parts of the design that we hadn't tested, but to see it working, we have the 4-inch gap between the ramp and the end effector. Obviously, because our end effector is traveling on the elevator, we can't have a solid ramp through. It would collide with some of the things on the top of the elevator, but the ramp is actually a 1/2 inch above our end effector's ramp, and so that allows for the coral to drop a little bit across that gap and us still be able to collect it.
Yeah. And so here we're kind of showing off. Mistakes are going to be made during a match, and there's going to be dropped coral. This is kind of showing off when there's a coral in your way, if you're still able to intake. Able to intake from the human player station. The height of our ramp right here is kind of sitting at 31 inches right now compared to the height of the 37.5 from the human player station. And we found this to work really well, and the decline that we have here seems to be working really well. Yeah. That about covers it for our hopper mechanism. Yeah, do we have any questions from chat?
So nothing in specific with the hopper mechanism, but if we can go back to LG and cover a couple things. Before we do that, we're going to start our giveaway from our friends at AndyMark for a $25 AndyMark gift card. So type in sport in chat right now for their new sport gearboxes and our sport options, and which you can also see on this Robot in 3 Days Robot. Type in sport, and don't forget, if you are a YouTube subscriber, you're going to get 3 times luck to win that giveaway. So click the subscribe button like so many have. We appreciate you. So I want to go back to a couple things with LG. I don't know if you guys read, but there's actually 2 different types of LG out there because there's different designs. Have you guys noticed anything with different LG, and what LG do you have? Are they the same or not?
Yeah, so we actually have seen 2 different types of algae. Just gonna grab this piece. We got one directly from AndyMark and then one directly from the kit of parts, and that's where we kind of noticed the different grains on here. One is very linear in terms of where it kind of heads in a singular direction, while the other one is a bit more radial. So yeah, that's kind of the big difference that we've noticed from them. For the most part, let's go and give them just kind of like a squeeze and whatnot. For the most part, they feel basically the same. You want to put them on the ground real quick. They bounce relatively the same, feel mostly the same. And when we inflated them to the gauge, and for the most part, they all seem pretty similar. But for the most part, there is a few irregulars with them, and sometimes they're a little bit egg-shaped. You can kind of see when they just kind of sit here and roll, they'll find an area where they want to bounce, like there's a high point or whatnot.
So a couple more questions on the LG, and then we do have one for the Coral as well, too. So for LG, do you think it's possible to shoot LG if you have motors at max speed? Will we see teams that shoot it, do you think?
Yeah, I think definitely we'll see some teams shoot it. I think shooting into the net is going to be a really big challenge. We kind of decided that focusing on the processor is going to be our goal, just with the net gain of a minimum of 2 points, considering if you score in the processor, you get 6 points, and then you hand it off to the opponent human player, who then has a chance to score 4 points in their own net. And ultimately, we decided this would be the most effective way for us to score from the algae.
I'm going to ask the Coral question, then we'll go back to the algae, because one that has to do with the reef. From your hopper design on here, is it possible that the Coral would fall out of the hopper at all, like if you're trying to do fast cycles or anything like that? That was a question from, I believe, Burak asked that.
Yeah, I think there's definitely the possibility of it. What we've seen from our previous testing, and once again, please go check out that video that we put out of our running testing and system. We believe that we should be able to get it in pretty fast. I do think there will be a few cases where it does fall out, but we'll have to see that once we get everything going and we're doing some full field cycling.
One last question to ask, and I know we showed something like this a bit earlier, but Touch Show for asking about level 4 interactions with the LG and Coral on there. Can you maybe just talk a bit more about how that settles, what it's like to take off the LG? Are you going to score points with Coral, that sort of thing?
Yeah. So we can go ahead and move some Coral on there right now. So with some algae already on there, and we drop the Coral on, you can see these two kind of sit at a bit of a different height. We noticed this one from AndyMark is a little bit different than the field spec one. It's just a little bit shorter, and that kind of gives it normally would sit right around here on the field spec, but on ours it sit kind of a little bit lower. And you can kind of see here, we have a little bit of a gap here. And from our testing, we kind of noticed that we were still able to get it out, but it did hit the Coral, and it kind of like knocks it up, and then it just falls right back down. Yeah. Awesome. Well, that about covers it for. Oh, we got some more.
Oh, we can do more. So.
Okay.
All right, so one more question that came in, and we're going to draw for the Thrifty Bot or AndyMark giveaway, sorry, and then we'll start a Thrifty Bot giveaway in just a moment. With your end effector that you have for the Coral, could you just pick up using the end effector instead of actually using a hopper?
I think you definitely could, but the big challenge with that is going to be able to become going to the ground and moving that entire system there. The reason we went this direction is because this allowed us to do a 2-stage elevator to get to L4, because we're starting at such a high point in our elevator, considering we're not starting at a low point on our second stage carriage. We can just go straight up like that, and we thought it was a pretty simple solution to the problem.
There are definitely going to be some people with mechanisms that probably tilt their end effector up to collect from the human player station, and then they tip it down in order to score onto the reef. That's probably a viable strategy. We just ended up going with the ramp design because it would fix our coral rollers, so we're not moving that system any more than up and down.
All right, let's go ahead and draw from our giveaway. Once again, that was for the AnyMark $25 card. If you win, please go to funroboticsnetwork.com and click the link on the bottom of the page in order to submit your information for that. The winner is going to be Chili Go Lizarax. Congratulations, Chili Go Lizarax. It's a great name, by the way. You are getting the gift card from our friends at AnyMark. We're also going to start another giveaway from our friends at the Thrifty Bot for a new product that's coming to the Thrifty Bot, the mitochondria. So that's coming soon. Take a look at thriftybot.com, but that's going to be your keyword. I'm going to put it in chat here because it's kind of a crazy word. Mitochondria is going to be your keyword. That's for a $25 Thrifty Bot gift card. And thanks again to both AnyMark and the Thrifty Bot for their continued support. And don't forget, if you are a fund sub, you do get 3 times luck to win on that. So as we start to look into the last day here, Cranberry Alarm, we're going to be doing our full reveal at noon Eastern. And if you miss it because you're in school or something else, don't worry. We'll have it archived at youtube.com under Fun Robotics Network. But what are kind of the immediate steps for tonight?
Sure. I think the first immediate step, now that we have everything mechanically put together as well as wired, we finished wiring up the elevator 30 minutes ago, something like that. It's just getting all the code tested, making sure all the motor controllers are configured correctly, running the right way, and so on. After that, making sure the controls can be upgraded away from like manual control to set point modes and things like that, just so we have better control to actually score game pieces accurately versus just kind of dialing the sticks. And then after that, I guess it's probably just like working on auto, refining anything that we find issues for or anything like that.
Yeah, we made a ton of progress. We just had a bare elevator at yesterday's recap. All of this superstructure went on, as well as the end effector mechanism, and we haven't done a ton of testing with the full system. And so I'm sure that we'll go through some integration issues and things that we'll have to figure out. But yeah, we're looking forward to getting this thing moving under its own control.
So something that's been coming up every single day, guys, is climbing, right? Everybody in chat keeps asking, what about a climber for things? Do you guys have a plan for that? I know you're talking to maybe one of the other Ri3D teams earlier as well, too, and there's some other Ri3D teams that are doing climb as well, too, that you might want to look at. But what's your guys' plan?
So currently we're not planning on shallow or deep climbing. For us, it would be a park, but we have seen a lot of different ideas for mechanisms, and then we actually saw Carmel's Ri3D team climb today, and that's very exciting from the deep cage. Reese, did you have something to say?
Yeah, I was just commenting on that. I think a big reason we're going to kind of forgo climbing, or at least for now maybe just really struggle with finding a good solution, is that we made a lot of design sacrifices to make coral really effective on this robot. For example, just the hopper and what that enables us to do is very limiting in that sense, and just how we made the elevator pretty simple. So I think when you go to do a lot of climbing, I think it's going to be important to plan for it and understand the sacrifices you may need to make if you want to optimize in another direction.
If we had a lot more time, I think that a perspective that one could have is, whoa, that's a lot of dead space on the other half of their robot. We've essentially crammed our coral and algae mechanism in the front, and there's plenty of room for activities over here, but with the time constraints, we decided to prioritize the other scoring mechanisms and those RP.
Yeah, so one thing specifically about the climb that kind of makes it hard too is, since we have a big manipulator and it's higher up, our center of gravity is higher, and so kind of the two things you need to consider when climbing is your center of gravity and if you're tipping. The climb we saw earlier, that, like they were mentioning from Rust Hounds, they bring the chain basically to from here to the center of their robot. So their center of gravity is like right under the chain, and that's not something our robot is already designed to do, but that's something to consider. I think I've seen a couple prototypes where the robot's intentionally tipping and kind of exploiting an offset center of gravity, so that might be something else to consider. But our robot design, like what Reese was saying, we've kind of traded off against that design.
We're going to just take one or two more questions. Don't forget to type in mitochondria, please, just once, if you want to win the Thrifty Pot gift card on there. So questions coming in from Kobe. Do you have an expected amount of coral algae that you'll be able to score in one match? Like, how did you approach that from a strategic standpoint?
Have we done the math? I don't know.
I think that'll be really interesting to kind of see. We at least expect that we should be able to do maybe 12 minimum. I know that's sometimes it may be a bit generous, or I guess what's the word?
Optimistic.
Optimistic, yeah, overzealous. There it is. But we hope that we can do that, and especially with how short the cycle distance is compared to last year, you're moving all the way across field. And even then, some teams were able to do 14, 15 cycles. This year, you're going to take a bit more longer to score it, but you're traveling a very short distance. And the fact that we have a pass-through is another reason that will enable us to cycle really fast, is we won't have to keep turning around every time we need to go score. So we feel pretty confident that we should be able to do a good number. It would be good, like Jordan said, to sit down and really do the math on it, but yeah.
Have you guys weighed the robot at all?
I was just about to mention this. We have not weighed the entire robot. We have misplaced our scale. We've yet to find it. Maybe we found it, but no, we haven't. We know that our robot last year roughly weighed like 70 pounds. With the end effector we have, I'd probably put us right around 90 pounds soaking wet. There's a lot of weight still to add, or a lot of weight budget still to play with if we had more time. And I think we might decide to drop some large weights on the back of our robot to offset our elevator and end effector sticking off the front.
All right, so last question we're going to take, and then we're going to draw for that giveaway. And if you have more questions that we don't get to, we'll try to answer them after this recording as well, too. We will be streaming until X amount of time, so stick around as well. So question coming in earlier, when you guys were showing off the LG into the processor, you mentioned that you might be able to do a little bit of a floor intake as well, too. Has that changed at all, or can you describe a little bit what you're doing for that?
Yeah, so this is what we're kind of mentioning with the versatility of the algae manipulator. We kind of expect that we'll be able to just rotate out like this and do some funky magic hand wavy programming. We should be able to pull this in, maybe move the arm at the same time, and then from there we should be able to go and drive over like this. Now this isn't going to be the most optimal way to carry a game piece around, as your intake's going to be out. This could be prone to defense, but we'll at least be able to hold on to it and potentially and drive over to the processor, and we can go and push over there and kind of see the scoring of that too. And from there, here we would basically just outtake, and then that should be enough to get us all the rest of the way into the processor. As you can see, like the arm is moving a little bit, so there may be some programming magic we can do there.
You're spoken like a true mechanical engineer, by the way. Just let programming worry about that. So let's go ahead and draw for the giveaway. Once again, from our friends at the Thrifty Bot, mitochondria was the keyword. If you do win, please go to funroboticsnetwork.com. Click the link at the bottom of the page for giveaway winners. And the giveaway winner is some random guy. So it's literally the name of the giveaway winner. So congratulations on that. Before we let the team get back to work, any last things you guys want to talk about? And of course, if you missed this or any of our other videos, check them out. Fun Robotics Network on YouTube. And we got a whole bunch of shorts and reels and TikToks as well, too. Fun FRC on Instagram and Fun Robotics Network on TikTok as well, too.
One thing real quick that I know it keeps getting brought up when people see our elevator up all the way is how tippy we are. So I'm interested to see, once we have the systems kind of all running correctly via code, actually see if reasonable driving around the reef is going to actually tip us over. And with that, like Corey was saying earlier, We don't think we're quite at the weight limit, so something we will consider doing is whatever weight we have left in the weight budget, putting that in the bottom back, kind of to balance out the heavy end effector.
And to build off of that, if you are curious about kind of the tippiness of this robot, we did do a tippiness test in one of our previous videos. We'll do another one once we got everything running, but be sure to check that out if you're curious on how that'll be. Yeah, in terms of other things that we're excited for, and to wrap up, we think this robot will be really competitive. A lot of the things on this robot worked out for us, so it's now just a matter of bringing it all together on the final stretch and just making sure it all works. But we're really excited for it, and hopefully you guys can learn a lot from this robot.
I'm going to ask just one last thing. Is the new radio on this robot?
Nope, we're using the old radio right now.
Okay. And then, are there any other motor controllers you want to mention? I know you mentioned the Nova earlier. Anything else you want to talk about?
No, like we mentioned before, we have Spark Maxes on Neos, and then the new Thrifty Novas also controlling Neos.
All right, guys, we're going to let the Robot in 3 Days team get back to it. It's the last night, so we can't wait to see it progress. If you can watch live, noon Eastern is going to be the time that we'll have the robot reveal. If you can't make it, don't worry. We'll have it on recording and Fun Robotics Network here on YouTube. So, guys, great job. This is awesome. All the inspiration been giving the teams and some great ideas as well. So good luck to you teams as well, and we hope to see you throughout the rest of the night and throughout the rest of the time. Thanks a lot, guys.